What's up, everyone? Welcome to the 100 sub special. Today we're gonna be doing a tutorial on how to use the built-in easy template PID tuner. I've had some teams ask me about it, and I said we would do it for 100 subs, and we hit that like a little bit ago. So, yeah. Now, you should be able to do this using just the normal easy template example project as long as you get your drivetrain coded. From there, it should all be fine. So inside of your initialize loop, there will be a line that says PID tuner disable. Just change that to enable. And then scroll down to your OP control. And inside of the while true loop, you're going to add if master.get digital button pros e controller digital B drive example. So this will just make it so that whenever you press the B button, it will run the drive example auto, which has it drive forwards 2 feet and then backwards 2 feet and then backwards another foot, or backwards, sorry, and backwards 1 foot and then backwards another foot. And then the line PID tuner iterate, which allows you to change the values on your PID tuner. So once you do that and you run your code on your brain, it should show this screen with 4 values on it. So first is P, and P controls how fast you go when you start moving. So you see P is at 0 right now. On the controller, we can use the Y and A buttons to increase and decrease the value. So whenever I press the A button, sorry, I was on the wrong value. Whenever I press the A button, it will go up by 0.1. And then whenever I press the Y button, it will decrease by 0.1. So first, I recommend just setting it to 1, keeping all your other values as 0, and then just seeing. So you can see there was a lot of oscillation. The robot was shaking back and forth on its path. So what that means is you have to increase the D, which stands for derivative. So using the up and down arrow buttons on the controller, you can change between these values. And D, every time you press the A button, it goes up by 0.25. So I'd recommend setting this to a higher value than P, such as 5. And then we'll see what happens. So now the oscillations are gone. However, it's still driving very slowly. So in order to fix this, just keep repeating this loop over and over again. So let's increase K to 2 now. All right, that was better, but it's still slow. And I would recommend going sort of exponentially on the increasing of the variables. So let's increase by 1, and that didn't change. So we're gonna try increasing it by 2. All right, that still looked good. Sorry. Okay, you can see there was a little bit of shaking right there. So let's try increasing the derivative a little bit. Right, so I think that means you increase the derivative more. I think you can kind of understand the concept here. Now, there's 2 other values on the screen that I have yet to explain, which is Ki and start I. So I stands for integral, and basically that just gives it another little boost when it starts driving, like if your robot's not making it far enough during its drives. And start I is the error at which I will apply. So essentially, error just is how far your robot is from your target. Now, it doesn't necessarily correlate to you like missing your target. It's just your raw distance. So if you're at the start, let's say your bot is right here and you want it to drive here, that means your error is about 2 feet. So if your start I is at a value of 30, that means that the integral will not apply during this drive. Okay, so that basically explains all of that. And then using the left and right arrow buttons on the controller, you can swap between the different constant. So you can see I already have all of these tuned for my robot. Don't copy these. These are different for every robot. This is just what worked best for me. So if you want, let's say you want to start tuning your turn PID constants, make sure you go to your autons.cpp file, and up here where it says default constants, set your drive constants to whatever you set them to on here. So for example, right now mine is 4010. So on here you would just 4010. Start I is optional. You don't need to have it. It will work if you don't have it, but you definitely need all of the other ones. And then so write those values in there. Then go to main.cpp, and where it says drive example here, you're going to want to switch that to turn example. Because this is just another example code project, which has it turn 90 degrees, then turn to 90 degrees, turn to 45 degrees, and then turn to 0 degrees. And so essentially, you just repeat this for all of your constants. Now, so on our robot, you can see we're just using an IMU. Right there, we don't have odometry or anything. So that means we only have to really tune the drive PID constants, the heading PID constants, and the turn PID constants, and the swing PID constants. However, if you are using odom, you do have to tune the angular and boomerang angular constants. So I think that pretty much about covers anything. If you have questions, you can put them in the comments. I'll try to do my best to answer them. Yeah, happy 100 subscribers. Yay!